Water is a major component of your body, not just your cells, but your body. It makes up about 70% of your body. Your cells are filled with water. Water is important because that's where most of all of your chemical reactions, your cell processes require water to take place in. It also allows for the diffusion of nutrients into your cells, out of your cells if they need to go somewhere else. It also helps you to store heat more efficiently. If you think about how long it takes for a pot of water to boil, you put it on the stove, it's going to take a few minutes. If you just turn your burner on and put your hand over it, it doesn't take very long for that heat above the burner to heat up. Water, it's going to take a lot more and it's going to take a lot longer to cool off too. In addition to that, we talked earlier about hydrogen bonds. Water is able to bond to itself because of those hydrogen bonds. It can also bond to other substances because of the hydrogen bonds. It causes that polarity, that opposite of charges. A cohesion refers to the attraction between substances of the same kind. Okay, an example is the surface tension in water. Where water molecules are sticking together, okay, you can kind of see the little Mickey Mouse heads there, okay, because again the hydrogen has the positive charge, the oxygen has more of a negative charge because of the hydrogen bonding and stuff, and so that allows those water molecules to stick together. In addition to sticking to itself, water can be attracted to different substances. This is referred to as adhesion. An example of this is seen in plant stems. Okay, water has to travel up from the roots to get up to the leaves of a tree, for instance. It's a long way for that those water molecules to move, and so it goes through a process called capillary action, in which the water molecules actually stick to the sides of the vessels that are transporting it. And this attraction, because of the polarity, in this case because they're two different substances, is adhesion. Because we know that water dissolves a lot of substances, a lot of things can be put into water. When we mix water and something else, it's referred to as a solution. It doesn't just have to be water. A solution is any mixture in which one or more substances are evenly distributed in another substance. Okay, and a solution is made up of both solutes and solvents. A solute is a substance that is being dissolved in another substance. Okay, solvent is a substance that dissolves another substance. So, for instance, salt water. Salt would be the solute, water would be the solvent. You make Kool-Aid, the Kool-Aid powder, the sugar, those are your solutes, and the water is the solvent. If you don't mix them very good, you get chunks in there, it's not a true solution, and it probably doesn't taste very well. The reason that water is so good at dissolving so many different substances is because of its polarity, because of those charges. Okay? Now, oil is nonpolar, water is polar. When you mix the two of them together, nothing happens. The oil kind of sits on the top, the water hangs out below. They don't mix together, they don't form a solution because the oil is nonpolar. Next up, we're going to talk about a little bit about acids and bases. Acids are anything that give off hydrogen ions in a solution. The eraser here. Okay, and because they're giving off a hydrogen ion, which is positive charge, they're referred to as a proton donor. A base is going to give off a hydroxide ion, the OH negative, and because it's giving off the electron, it's referred to as a proton acceptor. Okay, so even breaking down water, you end up with a hydrogen ion and a hydroxide ion. Now, the pH scale is a scale that measures the amount of hydrogen ions in a solution. According to your textbook, it ranges from 1 to 14. A more accurate would be 0 to 14. Okay, but 1 to 14 is fine for in here. So 7 is neutral. Okay, it's right in the middle. It's something with a pH of 7. Again, it is not an acid or a base. pH of your blood is probably about 7.3, 7.4. So it's just slightly over that neutral range, but not much. Anything below 7 is referred to as being an acid. The farther you get away from 7, the stronger the acid it is. Okay, so for instance, I'd say rainwater probably has a pH between 5 and 6, probably around 6-ish. Battery acid is going to have a pH of 0. It's a lot stronger of an acid. You don't want that on you. Anything above 7 is a base. Okay, baking soda I think has a pH of 8. Ammonia has a pH of 11. So as we're getting further away from that neutral point, those bases are getting stronger. And a strong base is just as corrosive as a strong acid.